units, right? So there's nothing unusual about that, and we've certainly seen that notation. And then I said for A equals, this might be where you have a problem, -2 raised to the C power. And I want to edit that caret. It uses, it's written 2 times -1 raised to the C, but you should know what that means. That's a button on your calculator, right? But it means raised to the power C. And that's a notation you should be amply familiar with by the time you come into this course, but if not, it's not hard to get used to. I've used it before. But I'm going to try to edit it so it looks like this. I don't guarantee that'll actually happen. Uh-oh. Why would I have that? I understand why you might have had some confusion on it. I've got to edit that, but that's easy. It's going to be the same, so it's got search and replace. It won't take me a minute. So that's the way it's going to read. Okay? And then it's times B. So it's going to look like this. Now, what's that? That's 2 multiplied by -1, in my case, to the 6th, times, in my case, 4. What's -1 to the 6th? Well, if we don't know how to take powers of -1, maybe we need to talk about it for about 30 seconds. What's -1 squared? -1 times -1 is +1, right? Now, if we multiply that by -1, we get -1, which is -1 cubed, right? And then the 4th power, we got to multiply by -1 again. That's going to make it positive. So for even powers, it's going to be positive, and for odd powers, it's going to be negative. So all I'm doing here is kind of randomizing whether you have a positive stretch factor or a negative stretch factor. So either you keep it above the axis or take it below. Right? I want to see how you do that. Okay? There's a 50-50 chance, depending on your... You can always change your name, but you never know if I'm going to change that letter or not, so it's probably not going to do you any good. And if you try to change it to all even letters, okay? Well, I could put a C -1 here, right? And I do, so I keep it, so it's random, but that's easy. Just put the numbers in. That equals 2 times 1 times 4, which is 6. Okay, then, K, it should have read H. H equals B times -1 to the C. And K equals C times -1 to the A. Okay, I'm not going to write out numbers, but you know, that's 4, and that's 6, so that's equals 4. And here K, A is 5, so that's going to be -6. Okay, so now you have vertical stretch, factor 6, horizontal shift of 4, vertical shift -6. Now the rest of this should be automatic. Now I say on this one, I want all the basic functions that are not power functions with integer powers. And we talked about that last time. List all the basic functions. There's a list from last time. And the ones that don't have integer powers. Now this can vary. I think there are at least 3 versions of this. So you got to know what the power functions with integer powers are, positive powers or negative powers, or non-power functions. So that would include okay, there are 9 functions. These 4 are not the ones with the integer powers. The ones with the integer powers are x squared, x cubed, x to the negative 2, x to the negative 3, and x to the 1 if you include that one. Kind of leave that as optional unless I say differently. Okay? So we got a graph these. Well, we get graphs that look like this. The x to the 1/2 function is like this, right? So now we're going to vertically stretch it by a factor of 6. So every point gets 6 times as far from the axis. Well, I chose a good number there. That shifts this point all the way up here. And it doesn't go to the left of the y-axis, but the point is it goes way up. And then what happens? We shift it horizontally 4 units, so we go over 4 units. Whatever you think 4 is, so it's going to shift over here. There's x equals 4. Then it's going to vertically shift at 6 units down. So it goes down 6 units. So this point goes down to here, and the graph ends up looking like this. And then you do the graph for x to the 1/3, 2 to the x, log base 2x, same thing. Okay? That's how transformations are done. But why are these the transformations? Here you're multiplying all the y values by a, right? Every value you get for f of x, you multiply it by a. That moves it 8 times as far from the axis and maybe upside down. Okay? Replace x by x minus h, and you shift h units in the horizontal direction. And then add k, you shift k units in the vertical direction. Okay? So that shouldn't be an overly difficult problem.